Hello everyone. So now let's move forward into the chapter. In the previous lecture, we have discussed what are the three types of numbers. What they are basically the natural numbers, the integers, the whole numbers. In the today lecture, we'll now going to move forward with the remaining types of numbers. So as you can see, the first type is the rational number and the second type is irrational number. And this we have already covered. They are the standard notations. You can refer to the previous lecture types of numbers part 1 if in case you are watching this video. So now let's move forward into the lecture and we'll try to understand these two types. So let's now try to understand the first type, which is nothing but the rational number. So what is a rational number we have to understand? So let me rub this one. We don't need this. And similarly this also. And this is the aim of the today's lecture. We will try to move forward to this one, what are real numbers. So you can see here I have just sketched a number line, and on that number line I have marked some numbers which we have already studied, like 0, 1, 2, 3, minus 1, minus 2, minus 3. So if I see the three different types, like if I see only this much, these numbers in this particular direction, so they are natural numbers. If I include 0, then they are whole numbers, and if I now include all these, then they are integers. Fine? It is not required now. So as you can see, in between any two of these numbers, there is some gap over there on this line basically, but this line is, this is number line. Fine. So we know between 0 and 1 there will be some number over here which is of our interest, which we want to understand. So this number between 0 and 1 is half. What this number is? 1 over 2. This number. So it is just one such number which we have identified, which lies between 0 and 1. Similarly, if you try to observe, like there are so many numbers in between any two of numbers on this whole of number line, even like here also, like here, here, here. There's so many numbers which we have not marked on this line, and what the numbers are basically the rational numbers. Now let me define it more precisely using the definition. So how a rational number is defined? Suppose I called, let me write it first. Fine. So this is the definition. A number x, this one, will be called a rational number if x has this form for some p and q, where p and q are integers and of course q is non-zero. So the p and q can be any of the number from this list. Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, minus 4, minus 5 and so on. So p and q can be any of the numbers from this list of integers which we have already studied, where p and q can be any of the integers, but provided q cannot be 0. You cannot take q equal to 0. So these are the conditions which this p and q has to satisfy. So such type of numbers are called rational numbers. Let's take an example of such numbers. If I choose p to be 1, q to be 3, then our x become 1 by 3. 1 by 3, fine. Similarly, for different choices of P and Q, you can find different x. If I take P to be 2, Q to be 4, then x will be 2 by 4. Fine, it is again a rational number. What type of number is a rational number? So you got a clarity. Now, why I have chosen this P and Q, because I want to now explain you another type of number which is called coprime numbers. So let me rub this. We have now understood this one. Now one more thing which you like to understood is coprime. Observe here that the greatest common divisor of 2 and 4 is, you just pause the video and answer it, try to think it once. The answer is 2. What is the greatest common divisor is 2, which is 2. So now 2 using, like, if I factorize it further, this rational number, this 4 can be expressed as 2 times 2. Fine. You can cancel this one. These two can be cancelled. Now this is nothing but 1 by 2. So this x, this was our original x, and now it reduces to this one. So in this case, we'll say that this rational number is equivalent to this one. They both will be called equivalent. Let me now rub this definition. We have understood this. One more thing, equivalent. What I'm saying, equivalent term I'm using. So this 1 by 2 and 1 by 4 are equivalent. This is such an example. 1 by 2 and 1 by 4 are equivalent. Not equal. Equal means different. Equivalent is different. These two are equivalent. What I mean by this, if you try to divide 1 by 2, sorry, here should be 2 by 4. I'm sorry. It should be 2 by 4. So if you now try to find their values, use ordinary method of division. 1 by 2 will come out to be 0.5, and similarly 2 by 4, if you divide, it will going to again come 0.5. So the value they have are same, but their representations are different. If you see, both of them looks different. So they are equivalent because they have the same value, but they are not equal. Fine. So now this GCD is 2. If in case, whenever I take a rational number, I take a fraction, if their greatest common divisor is 1, then such numbers will be called coprime. What I mean by this? Coprime numbers, basically those x of the form P by Q where GCD of P comma Q will be 1. So we have now understood what are rational numbers, what are coprime numbers, what are equivalent numbers. So rational numbers also called fractions sometimes. So let me rub this and now give you some basics of like clarity behind the rational number. This rational number, rational numbers. This term, this rational, is come from the word ratio between. Ratio. From the earlier classes you have studied what is a ratio, and here in the case of rational number we have taken ratio of two integers P and Q. Fine. So there is a standard notation we use. This Q. This Q is nothing but standard notation. This is the standard notation for denoting the collection of numbers called rational numbers. Now you observe, in the case of integers, in the case of natural numbers, in the case of whole numbers, they are infinite. There are infinitely many numbers. So similarly, in the case of rational numbers, if you try to observe, if you try to see, like between, I have just pointed out 1, I have just pointed out one rational number between 0 and 1. Here is another 1 by 4. Here is another 3 by 4. Likewise, if you try to find, but if I, like this is a piece. This is from 0 to 1. Here is 0. Here is 1. So this length, this much, from 0 to 1 has infinitely many rational numbers. How many rational numbers are there? Infinite. So between 0 and 1 there lies infinite many rational numbers. Rational, simply, or you can say fractions. What you can say? Fractions. Fine. One more thing I want to you should observe one more thing. Let me rub this one now. That the equivalent one with the previous equivalent fraction, the example was 1 by 2, 2 by 4. Likewise, you observe 4 by 8, 8 by 16, 16 by 32. These all are equivalent. These all are equivalent. Don't you observe that this list can be like this collection can also be go in a similar fashion? What is happening basically, every time the denominator is twice the numerator. So the next number will be, oh, I'm sorry. Wait. It should be 32. Likewise, 32 by 64, 64 by 128 and so on. So these are infinitely many equivalent fractions. So which reduces simply to 1 by 2 or its value is 0.5. Its decimal value is 0.5 with all these fractions. So you have for each fraction, each rational number, there correspond infinitely many choices of equivalent fraction, or simply we can understand it like that, corresponding to every fraction or every rational number there are infinitely many equivalent fractions. Fine. So now we can rub this. So we have understood what are rational numbers and how many they are in number. Fine. What is a rational number? It is nothing but a fraction of the form p by q, where p and q are integers, but q cannot be 0. So observe why q cannot be 0. Pause the video, try to answer it yourself. Why q cannot be 0? Because I give you a clarity on this. Just a remark again. It's a remark. It should be understood before moving ahead. X was this. Q was, we are asking that q cannot be 0. Now this is a problem which we should address. Why? So we have to give a reason why q cannot be 0. Let's take an example again. Suppose I choose a very simple one, p to be 5 and q to be a number, because it is asking that q cannot be 0. So can I take a number close to 0? I am not asking q to be 0, I am asking q to be a number close to 0. Let's take a number close to 0, 0.1. I have taken a decimal, 0.1. Now if I solve it, what I find, it is 5. This 0.1 means 1 by 10. This 5 can be written as 5 by 1. This was 1 by 10. If you now, because it is a denominator in division, if you now if you take its reciprocal from the it will be reduced to 10 by 1. The answer is 50. The answer is big enough in comparison to the numerator. Observe. If now you choose a number smaller than 0.1, 0.01, now choose. Still I haven't taken q to be 0. This is satisfied. But I have taken a number which is close enough to 0. Observe. This is close enough. Let me rub this one. Close enough to the number 0 but not equal to 0. Fine. The reason, if now in this case you will solve, the answer will come out to be 500. This will be 1 by 100, 20 will come extra. Fine. So if now it go close and close to 0, like previous one was 0.1. Let me sketch this part only of the number line. This is 0, this is 1, this is 1 by 10 or simply 0.1. Now you are asking 1/10 of this value, so it will be somewhere here 0.01. In fractions it is 1 by 10 and it is 1 by 100. Fine. Now if I ask you to take the 1/10 of this one, 1/10 of this much, this only this much part, it will be how much? Again one more 0 will come. This one. And this will increase to only one more 0 will come. 5,000 and so on. So you observe some pattern. As soon as you move close to 0, for the choice of Q, the rational number which comes out, this is our answer. This is the rational number, rational value. I will say it a rational value. This is our answer, basically the final one, the final answer. So this value is large and large. This symbol is just to note it is increasing as you are going close to 0 for the choice of Q. Observe one more thing, that in just for the sake of explanation and understanding, I am taking values which are close to 0 and indeed they are rational, they are decimals. I am not choosing Q to be integer for giving you clarity why you cannot choose Q to be 0. So because if you are just close enough to 0, the value is becoming so large and large. If you take the number to be 0 itself, it will be infinity. It will be so large, it's out of the context totally which you are trying to study. So that's the reason we cannot divide by 0. We cannot take Q to be 0. I hope you got a clarity on this. So let me rub this now. This is very clear. This is the remark. Still we haven't answered this problem. So I feel we can conclude this lecture with the understanding of rational numbers, and in the coming lecture we'll be studying what are irrational numbers, and finally we'll be concluding what are real numbers, what kind of numbers these are. We have understood, still there are some numbers which are left over on this number line to be represented, and they are irrational numbers. So we will be studying about that in the next lecture. And I just want to give you again an information that we have our official Facebook page in the name of Vigyan Bharat. Its username is Vigyan Bharat 2020. You can find the link in the description, and do share about Vigyan Bharat, this initiative which we are working on. It's totally free for students for the secondary education, as well as all the mathematics is completely free. So I ask you to share about to your friends, so that they can also make a maximum utilization of our content. So thank you so much.